Hey guys, Mr. Middleton here. Today we're going to talk about proving triangles similar. At the end of this video you should be able to use the three methods from today's lesson to explain why two triangles are similar. Okay. Alright. I guess we'll start off by saying that there are three ways to prove that triangles are similar. So very similar to our congruent chapter. We started off talking about how any figures can be congruent, and then we simplified it to talking just about triangles. And so we're doing the same thing here. We talked about what similar meant as far as all polygons, and now we're going to just talk about triangles. Okay, our first method is angle-angle similarity. So, angle-angle similarity says if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. Now notice we only say two angles because triangles have to add up to 180. So if two angles are the same, well, we know the third angle has to be the same. That means all the angles are the same. That means the triangles are similar. So here, angle, 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 we have angle, angle, similarity. And for our similarity statement, we'll do the same thing as we did last chapter, making sure that we follow a pattern. And so my pattern, I'll go from one mark to two marks to no marks. So I'll say triangle TRS is similar to triangle PLM. Okay, angle, angle, similarity. Okay. The second method for triangle similarity is the side angle side similarity. Now notice I put the similarity sign there, okay? Because if I just said side angle side, that was our congruence postulate. We have to differentiate a little bit. So if two sides of a triangle are proportional or proportionate to two sides of another triangle and the included angles are congruent, then the triangles are similar. Remember, sides need to be proportional, angles need to be the same. And so when we look at this, this example says, why are the two triangles not similar? Well, let's look at what we got. We got two sides, and we have the angle in between them congruent. So why are they not similar? Well, we always have to make sure that our sides are proportional. So 3 over 6, I did small over big, equals 1/2. We need to make sure that this has the same ratio. 4 over 10, which simplifies to 2/5. Okay, so notice that 1/2 is not equal to 2/5. So why are they not similar? Sides are not proportional. Alright, and sides need to be proportional to prove by side angle side similarity. Final one on this side, we have side similarity. And side similarity says if all the sides of one triangle are proportional to the corresponding sides of another triangle, then we know that the triangles are similar. And for this problem, again, we're showing that the sides are not proportional. And so we're going to use an extended proportion here. And remember the rule, largest side goes with largest side. Smallest side goes with smallest side. A lot of people tend to do 3 and 3 because they have the same numbers. Don't do that. I'm going to take the smallest side of my small triangle, 2. I'm going to match it with the smallest side of my larger triangle, 3. The medium side is 3 here. I'm going to match it with the medium side here, which is 4.5. And then the large side here is 4. I'm going to match with the large side here is 6. Okay, when I simplify all these, it should go down to the same thing. Okay, 2/3 simplifies to 2/3. 4/6 simplifies to 2/3. 3 over 4.5. When I do that on the calculator, 3 divided by 4.5. Hey, that's 0.6 repeating. I know that's 2/3. Notice that all of these are the same, so they are proportional. Okay, this is the side similarity. We could use this side similarity, to prove that these two triangles are similar. So I can say triangle, and now I'll do short to medium, ABC, is similar to triangle, short to medium, FED. That would be my similarity statement. And my similarity ratio would be 2 to 3. Okay. Flipping to the back side. Okay, big takeaway that I want you to know is that you must prove that triangles are similar before you can find a missing side, a missing angle, or set up a proportion to find a missing side. So what happens a lot is in this chapter is that people say, oh, I do proportions. I see triangles, I do proportions. Remember, you can only do the proportions once you prove that the triangles are actually, or the sides are actually proportionate, which happens if the triangles are similar. So, first example says, find the length of ST if possible. If possible is a big thing. So, they gave us two sides and an angle. So they're probably going for side, angle, side similarity. Remember, for side, angle, side, and similarity, we need two sides and an included angle. So we're given these two sides, but look here. ST would be the side that would include angle T. Even though we're given an included angle here, we're not given it here, so we do not have enough information. Not enough information in EI. Okay, we cannot prove that the triangles are similar first, so we can't find ST. Okay. All right, looking at the next problem, we have this angle, these two triangles that we're trying to find X. Kind of see a bow tie problem. You see vertical angles. All right, and so now we have angle similarity. Sorry. All right, and so our corresponding sides, we have, I'll say 24 over 14. What does that simplify to? 12 over 7. Okay, 12 over 7 is our similarity ratio. And so we'll use that similarity ratio and say, okay, 12 over 7, that's the large over the small, should be the same as 22 over x, large over small. Cross multiply, 140, 154 equals 12x. Divide both sides by 12. 154 divided by 12. 12.83 repeating. Yeah. So that is 12.83 repeating, and that would be like what, 12 and 10 12 and 5/6. Okay, so that's 12 and 5/6, I believe. Hope so. All right. Next problem. It says find the length of MP if possible. So for that, what we want to have is we want to try to prove that two triangles are the same. I got you. And MP is a part of this small triangle here, right? And we have this large triangle here. So what we can try to do, we know that angle N is going to be the same. It's a shared side, right? So we have 8, 8, side angle side. And for the large triangle, and I'll just draw this out so that we have it and you can see it, we have this side in Q is going to be 18. This side in R, which is going to be 18. We have this angle. Okay, so these two triangles are similar, and they're similar because of side angle side similarity. And we know that didn't have to do a whole lot of math because 8 over 18 has to be the same as 8 over 18. Okay, so they are similar. And so now we can use this ratio, which I'll simplify to give me 4/9. We can use this 4/9 ratio to find, I'll just mark this as x. Okay, we did the small x over the large 27. That is 108 equals 9x. And so x will equal 1 to 12. Okay. Final question asks us for measure of angle Q. Okay, they told us that the measure of angle J is 29. Told us that the measure of angle L is 34. They want us to find the measure of angle Q. Now, before we do any of that stuff, we need to make sure that we prove that these two triangles are similar. So, again, I'm going to do small side over small side. So 32 over 22. I'm going to do medium side over medium side, so 45 over 30. I'm going to do large side over large side, which is 60 over 40. Okay. All right, and now once I simplify that, that gives me 3/2. I know that much. That gives me 3/2. I know that much. That does not give me 3/2. I do not know what that simplifies down to. 8 to 16 over 11. Okay, which is not the same. So we see that these are not similar triangles by side, side, side. And so we can't find angle Q. If we don't have similar triangles, we can't just say it's going to be the same as an angle. So not enough information, or not similar. This is actually not similar. Kind of prove that they're not similar by doing that side, side, side. Okay, because the sides are not proportional. Okay, indirect measurement. We can use indirect measurement to find the heights and lengths of, we'll say, large objects, really large objects. Okay, there are two forms of indirect measurement. We have mirrors and shadows. Nope, sorry. I'll change this to the first, is the first form. Okay, because this one is using a mirror. Okay. The angle of incident is always equal to the angle of reflection. So what that basically means is as the sun comes in, the same angle that it comes in, it goes out. Okay, the light, as the light comes in, the same angle that the light comes in, it bounces out. Okay, and so just trying to make sure that we know why we can use this indirect measurement. Notice that when we talk about a height, we're always talking about a perpendicular height, and I know I'm using black on gray, so hopefully you can see where I'm talking about. We're always talking about a perpendicular height, so that means this has to be a 90-degree angle. And what we just said is the angle of incidence, the angle it comes in at, is going to be the same as the angle it exits at. So these angles are going to be the same. And so that means we have angle-angle similarity. All right? Okay, and because they are similar, I can find the height of the geyser. And so I'd like for you to try to find that height to the nearest tenth and bring that to class for me. I'll be looking for that when I check your notes. Okay, using these measurements. All right, see ya.